All right, class, we're going to start Chapter 6 today. And Chapter 6 has to do with fractions. So we're going to simplify fractions. So a lot of the basic math we learned back in elementary school with fractions holds true. But I just wanted to remind you about a few things before we get started. Now let's look at number 1. My question is that true or false? What's changing places there? Yeah, my negative sign. Now, would we say that is a true statement or that is a false statement? That's right. I would say that's a true statement. It doesn't really matter the placement of the negative sign as long as the negative sign is there. So if it's in the numerator or if it's in the denominator or if we put it out in front, that's okay. Now, my little addendum to that is, let's say I had negative 1/3 over negative 1/3. Yes, remember, a negative divided by a negative is a positive, so this would equal positive 1/3. Now, let's look at number 2. If I look at fraction number 2, how would I simplify that fraction? What do you think I would have to do? Yeah, remember we learned back in Chapter 1 that the fraction bar is like a grouping symbol. So I take care of the math in the numerator, and the numerator says 9 plus 5, and that's 14. And then I look at the math in the denominator, and that's 9 plus 2, and we know that's 11. And then when I look at that fraction, can I reduce that fraction? No, it's a done deal. Excuse me. Look at number 3. How would I simplify number 3? Well, some of you would say, oh, Miss Burton, we've got 9 times 5, which is 45. That's the math in the numerator. And if I do the math in the denominator, then we got 9 times 2, which is 18. But then Mrs. Burton would say, hey, can you simplify that fraction? And you would say, oh, yeah, my GCF is 9. All right? And so then we'd get 5 over 2. Now, some of you may have realized because this was multiplication over here, I could have canceled those 9s. All right? So, question, big important concept, okay? Realize when I'm adding like I did in number 2, I can't cross out those 9s. Okay, we can only cancel something. We can cancel if there's multiplication. And so that's why it works for number 3, but not for number 2. All right, so now let's see how that's going to work for us as we try to simplify algebraic fractions. So if you look here on number 1 says, you know, Mrs. Burton's got to have a little honey-do list. We're supposed to factor the numerator and denominator. Well, that does mean that our honey-do list for factoring is still in play. And I'm going to say rule number 1, or that GCF, is very important. We're going to see that a lot. Okay? Rule number 2 says reduce. Remember to look for factors that are opposite. We may have to use the -1 thing. We're going to simplify. And the new thing here is state restrictions. Now that's new for us. And the idea of restrictions means we're going to look at the denominator. And you and I both know that the denominator cannot equal 0. If the denominator equals 0, then it's undefined. So we're going to see this is going to boil down to 2 steps. The first thing that we're going to have to do is we're going to have to look at our fraction and see if there's anything that we can factor. Okay? So we'll look at it. Does any part of the honey-do list apply? And we'll factor. And then after we factor, something almost always cancels. So that's going to be our battle cry in 6-1. So let's see how that works. If I look at the numerator of this first problem, what part of the honey-do list works there? Yeah, I've got a GCF. And so my GCF is 3. If we factor out a 3, I'm left with 4m minus 5n, and then I've got a 9 in the denominator. Now, can I cancel anything? Or can I reduce anything? Yes. Did you realize this fraction out here? 3 9s can be reduced to what? 1/3. So we'd be left with 4m minus 5n over 3. Now, do we have a restriction for this fraction? there's no restriction. We're going to find out that restrictions only occur when I have a variable in the denominator. So no restriction on equation number 1. Now, let's look at fraction number 2. If I look at fraction number 2, well, what can I factor? Let's look at the numerator. Does any part of the honey-do list work in my numerator? Yes, I have a GCF. So we're going to factor out a 4, and I'm left with n plus 4, and now I have n plus 4 in the denominator. Now remember, if I have the exact same binomial, top and bottom, then I can cancel those out. So n plus 4, that binomial is going to cancel out the n plus 4 in the denominator, so my answer I'm left with is 4. Now, did you notice that I actually had a variable in the denominator this time? So if I have a variable in the denominator, then I have a restriction. And so we've got to figure out what could n be that would make the denominator 0. Well, hopefully you realize n could not equal -4, because if we plugged a -4 in the denominator there, we get -4 plus 4, which is 0, and that can't happen. All right, so let's go forward and try a few of these together. Let's look at number 1. So again, we saw that pretty much it's going to boil down to let's see what we can factor, the honey-do list, and then we're going to find out what we can cancel. So factor cancel is our battle cry. So let's look at number 1, and I look very meticulously at each part of my fraction. If I look at the numerator here, is there any part of the honey-do list that applies? Oh yes, there's a GCF. What are we going to factor out? We're going to factor out a 6, and I'm left with y plus 5. Now let's look at the denominator. Is there any part of my factoring honey-do list that applies? Well, there's no GCF, but there's 2 terms. Do you recognize what that is? Yes, good job. That is difference of perfect squares. So remember, that's going to factor to its conjugates, or sum and difference. So now we've got the numerator factored. We've got the denominator factored. Now, is there anything that cancels out? Yeah, I've got a y plus 5 in the numerator and a y plus 5 in the denominator, so they cancel out. So my answer is 6 over y minus 5. Now, do we have a restriction? Yes, we've got to go back up to our factored form, and we actually have 2 letters in the denominator. So what could we plug in for either one of those y's to get 0? So hopefully you could see y could not equal plus or minus 5. If I plugged in a -5 there, we'd get 0. Or if I plugged in a +5 there, we would get 0. So that's why my restriction is plus or minus 5. Now, good job. Let's go over here and look at number 2. If we look at number 2, is there any binomials that will factor out automatically? Yeah, did you realize 2x plus 7 is the same thing as 7 plus 2x? We've said that over and over again. Addition is commutative, so they cancel. Now, we got to go way back. Does anybody remember what these are? Chapter 4 is where we first saw them. That's right, they're opposites. How do we get opposites to cancel out? Yeah, we're going to multiply by -1, and so that will rearrange this to be x minus 5, so they cancel. So here my final answer is -1. Now, we've got to look at our factored denominator. Did you realize I've got 2 restrictions? So, if you're not sure how to figure out what it is, if you take whatever's in the denominator and make it equal 0, that will help you. And so now I'm going to subtract 5 from both sides. So we've got -x equals -5. So there, x cannot equal 5. And then we're going to take the second part. I'm going to equal 0, 2x plus 7. And we're going to subtract 7 from both sides. So now I've got 2x equals -7. So x cannot equal -7/2. Good job. All right, let's go ahead and look at number 3. Simplify, give any restrictions on the variable. So if I look at number 3, and we look up there at the numerator, Is there any part of the honey-do list that applies? Oh yes, we have a GCF. And if I look there, it's a number thing and a letter thing. Between 4 and 8, our GCF is 4. And between p squared and p, which one do we factor out? Yeah, we always take the lower exponent. And so what's left? Well, if I find the factors that remain, we're going to get a p minus 2. Remember, we divide our GCF, and we've still got 4p cubed in the denominator. Now, do you see anything that simplifies or cancels out? Yeah, our 4's would cancel out. Now, we've got p over p cubed. Do you remember how we did that back in chapter 4? Yeah, if I'm dividing and I have the same base, remember we subtract our exponents. So we've got 3 minus 1 is 2. And remember, we put the answer back where the bigger exponent is. So we've got p minus 2 left in the numerator over p squared. And because we've got that letter variable in the denominator, my restriction is that p cannot equal 0. Good job. Okay, number 4. Now, look at this little guy right here. What do we call him from way back in chapter 5? A binomial squared. That's right. I'm going to go ahead and write him down twice. A minus 5, A minus 5. It'll help us see what we need to do. Do you recognize what's in the denominator? Yeah, that's a difference of perfect squares. So we're going to have 5 minus A and 5 plus A. Do we have anything we can cancel? Great job. Did you realize these guys right here were opposites? Remember, opposites, there's a minus sign between them, but the letters are switched. Order matters with subtraction. So in order to get those to cancel out, I got to multiply by -1. So here's what I like to do on that one. I like to put a negative sign out in front, and then we've got A minus 5 left in the numerator and 5 plus A left in the denominator. And we've got a restriction. What can A not equal? Good job. Plus or minus 5. All right. Now, last problem for the day. Let's see what it's got. Okay, so this time we have a trinomial in the numerator. Well, is there a GCF? Because that's rule number 1 of factoring. No GCF. How do we factor 3 terms? Oh, yeah. Okay, we're going to use X factor. So how do we do that? Well, we need the factors of 3t squared. So that's 1 and 3. T squared is t and t. What do we know about our signs? Very good detectives there. That last sign is negative, so we need 1 plus and 1 minus. And now, factors of 7. Okay? Well, let's make it 1 and 7. And then we've also got that v squared, so we need to put some v's in here. Okay, every good algebra student uses X factor to check the middle. So 1 times -7 is -7tv. And then 1 times 3t is 3tv. And if I put those together, hey, guess what? We have chosen wisely the middle checks. So that means my numerator is t plus v, and then 3t minus 7v. So we factored the numerator by using X factor. Let's look at our denominator. No GCF, but there's only 2 terms. Do you recognize what that is? Great. That's difference of perfect squares. So to factor that, I need conjugates or sum and difference. Now that we've factored everything completely, what will cancel? That's right. We can cancel the t plus v's. So final answer, 3t minus 7v. All right. And then in the denominator, we got t minus v. Now, we do have letters in the denominator if we go back up here and look. So what's my restriction? Good job. Kind of weird. T cannot equal v. What would happen if t equaled v and we were subtracting? Yeah, we'd get 0. So that is my restriction. All right, final answer. Great job.